Hi everyone! Today let's talk about section 12.5, chain rule. Suppose we have a function f of xy. Suppose that each of x and y is a function of some other variable t. For example, f of xy might represent the temperature at a point xy in the xy plane, and x of t, y of t may represent the position at time t of a particle moving in the xy plane. Then the temperature experienced by the particle at time t is given by the composition, okay? G of t is f of x of t, y of t. If we want to figure out how fast the temperature is changing for the particle, moving particle at time t, we will need to compute the derivative of g with respect to t. Okay, so here we're gonna have the multi-variable chain rule. Okay, it says the derivative of f with respect to t equals partial f partial x times dx dt plus partial f partial y times dy dt. So far so good. It's very similar to what we had before, right? Dy dx is dy du times du dx. Okay, but here y is a function of u and u is a function of x. But in this case, because f is a function of x and y, so what do? You just look at each variable respectively, then you add the answer. Okay. So compare this to the chain rule from Cal 1, which says that for the function fx and x of t, then yes. So this is the chain rule if f is a function of x, okay? Only one variable calculus, okay? One variable function. So example, let f of xy equals x squared plus 3xy and x of t equals cosine t, y of t equals sine t. Consider the composition g of t equals f of x of t, comma y of t. Okay, find the derivative. So here, you see, this is the ordinary derivative because g has only one variable, that's the t. Okay, so that's why we have ordinary derivative for g. So let's find the derivative in two ways. First, do it by direct substitution and the ordinary differentiation. Okay, so let's substitute in it. So g of t equals f of x of t, y of t. It means whenever you see x in the formula, replace x by cosine t. So x squared becomes cosine t squared. And then 3x, x is cosine t, y is sine t. Okay, so now what is the derivative? Well, derivative of cosine squared, chain rule 2 cosine t, and then the derivative of cosine t. And then next is the product rule. So 3 cosine t prime sine t plus 3 cosine t times sine t prime. Okay, so I hope you're fine. This is chain rule, and the second term we use product rule. Okay, derivative of cosine is minus sine t. Derivative of cosine is minus sine t, but sine t times sine t is sine squared. Derivative of cosine is cosine, so cosine times cosine is cosine squared. So far so good, everybody? Alright, let's compute the derivative by using the multi-variable chain rule. So, okay, what is partial f partial x? Well, partial f partial x is, we take the derivative of f with respect to x, x squared derivative is 2x, 3xy derivative is 3y. Partial f partial y is derivative of x squared, because it's a constant, so the derivative is 0. And then 3xy, derivative of y is 1, so we just get 3x. And then we have dx dt. Derivative of cosine is minus sine. dy dt. Derivative of sine is cosine t. So multi-chain rule tells us that dg dt is partial f partial x dx dt plus partial f partial y dy dt. Okay, but you also need to plug in what's your x, what's your y. So 2 was x, x is cosine t, right? Let's see. Yeah, x is cosine t, y is sine t. Okay, so plus 3y, y is sine t. And then dx dt is negative sine t plus partial f partial y, 3x, x is cosine t, dx dy dt is cosine t. Let's distribute it. So 2 cosine t sine t minus 3 sine t squared plus 3 cosine t squared. Are they the same? Yes. So far, so good, everybody. Okay, let's continue. Generalizing the chain rule. Okay, 2 independent variables. So if we have function f of x, y, and each of x and y is a function of 2 variables t and u, we may want to find the partial derivatives. So partial derivative with respect to t and a partial derivative with respect to u. And the chain rule work pretty much the same way as before, but now because x and y, they're a function of t and u, so the derivative is going to be partial derivatives instead of ordinary derivatives. So far, so good? Okay, let's work on the following example. Okay, so first, let's figure out f(x). Okay, derivative with respect to x. Wow, derivative sine is cosine 2x, chain rule, so we have 2, and the tangent 3y stay there. Right? How about fy? Sine 2x stay there. Derivative of tangent is secant squared. Because of the chain rule, we have the 3 in front. So far, so good, everybody. Okay, and then what is x, t? Okay, so partial x, partial t. Well, derivative 4t squared is 8t, e to the u derivative 0, x u, 4t squared derivative 0, e to the u derivative is e to the u, yt is derivative of t is 1 5u cubed, yu derivative is back to u cubed, derivative is 3u squared, 3 times 5 15t u squared. So far so good, everybody. Okay, so next partial f partial t is gonna be fx, xt, fy, yt, right? Yeah, I love to use the shorthand notation, then we can write less symbol. Save some time. So, but if you're not familiar with that, just go ahead and change your symbol to partial f, partial x, partial t, etc. Okay? And when we plug in, don't forget to replace your x and y. So this is fx is cosine 2x. So that is 2 times 4t squared plus e to the u. Don't forget another parentheses. Otherwise, they will think of this is like cosine 2 times that. Okay, so we want to have cosine of the big term inside of the cosine. Okay, so xt is 8t. Oh, sorry, not yet. And we still have the 2 and tangent 3y. 3y is 3 times 5, 15. Okay. Okay, so this is partial f partial x. Yeah, quite long. Xt is 8t. So far so good. Plus fy. Fy is sine 2x 4t squared plus e to the u, the whole thing, times 3, and secant square 3y. Oh, still 15t u cube. And yt is 5u cube. Yeah, because you see the function is getting more and more complicated. So after you're done, I strongly recommend you to check your work. Okay? So we have fx, xt, fy, yt. Okay? Let's continue. And if you don't simplify your answer, that's fine. You can leave it like that. Or you can multiply the constant together. 2 times 8 is 16. 3 times 5 is 15. Okay, but don't multiply this 2. Okay, this 2 is inside the sign. This is what I'm worried about. This guy and this guy. So these two numbers that are inside the trig function, you cannot put it outside of the trig function. Okay, so sometimes I'm worried about my students. They get the right answer, but when they try to simplify, they make some algebra mistakes. And then, yeah, every time I see that, I really wonder, you already get the answer, but then you make some mistakes. What a pity, right? Okay, partial f partial u is fx xu. Fy, yu. Well, it's very similar to what we have done before. Just replace these two terms by this guy, right? So save us some work. We can just copy this whole thing down. No, this is t, not plus. And okay, instead of 8t, xu is e to the u. Okay, and then we have plus sine 2 4t squared e to the u 3 secant squared 15t u cubed. Okay, instead of 5 u squared, we have 15t u squared. Okay, so this is the answer for this example. So far, so good, everybody? All right, let's continue. Let f, so this is a function of 3 variables, and x, and x is a function of t and s, y is a function of u and s, z is a function of s and u, t. Okay. All right, let's see here. So fx is gonna be a big problem. So remember to write tiny so that we can have more space here. So fx is cosine 3y is gone. 4x squared derivative is 8x. So 8x e to the z. Right? Fy is derivative cosine is minus sine. So because of chain rule, we have a copy of 3. 4x squared is e to the z has no y in it. So gone. Fz cosine 3y has no z in it. Gone. E to the z derivative is e to the z. But also the constant multiple stayed there. Okay. And then let's look at x. Xt is derivative of ln of t is 1 over t. Xs is 2, right? Oh, there's no u, so it's 0. Y, t, no t, 0, y, s. Derivative sign is cosine, so minus cosine s. Y, u, 3 times 7, 21 u squared. Okay? So a lot of information. Be careful, calm down, do it slowly. Derivative of t. Woohoo. So this guy is u. Let me see. Let me make sure. Is this is cube roots, right? Oh, okay. I don't know. Let me emphasize here. This is cube root of t. So it's not u cubed times square root of t. It's u times cube root of t. Okay. So t to the 1/3. Okay, so the derivative of t to the 1/3 is, we move the 1/3 in front, so 5u over 3, and then t to the minus 2/3. So far, so good, everybody. Oops. And then zs, 11. zt u is, so derivative of u is 1, so 5 times t to the 1/3. Whew, okay, now we're ready. So partial f partial t, what is that? What is fx, xt, fy, yt, fz, zt? Okay, fx, 8, x is ln of t plus 2s, e to the z is 11s plus 5u times t to the 1/3. Okay, this is fx. xt is 1 over t. And then, oh, you see what happened? Yt is 0. Then we don't need to put down fy. And then fz, 4 x squared is ln t plus 2s squared, e to the z, 11s plus 5u, t to the 1/3. zt is 5u over 3, t to the negative 2/3. Is that okay, everybody? Quite long. Okay, how about partial f partial s? So let's see here. So this is fx, xs, fy, ys, fz, zs. So fx stay the same, so we still have 8 ln of t plus 2s. Just copy what we have before, like here, right? S plus 5u t to the 1/3. Now multiply by xs, 2. And then fy, okay, fy is negative 3 sine 3y. But y is 7u cubed minus sine s. Okay? Times ys negative. Okay, negative become positive cosine s. And fz is, this guy is fz. Ooh, do I have enough space? Let me try to write as tiny as I can. Okay. Give me some space here. I might not have enough space. Okay. And zs, zs just 11. Good. Okay. Oops. Sorry. Okay, good. I can fit in one line. And then partial f partial u. Fx, xu, fy, yu, fz, zu. Fx, this fx still the same, so let's copy it down here. Okay, times xu is 0. Oh, I don't need to copy it because it is 0. Okay, 0. Let's continue. So fy is minus 3 sine 7u cubed minus sine s. Okay, yu is 21u squared. Okay, plus, now I don't have enough space. Okay, let's do it another line. Fz is 4 ln plus 2s squared e to the 11s plus 5u t to the 1/3. Okay, zu is 5t to the 1/3. Okay, so that is our answer. It's quite long, but it's not very hard, right? Look at each of the term is very simple differentiation, but you need to organize in a good way. So make sure you organize them better, and then you don't miss some terms. Okay? And slowly, do it slowly. Calm down, be patient. Okay, even though you might feel bored, but please calm down. And after you're done, check your work. Okay, because this process is quite long. It's very likely we might make mistakes. So check our work. Okay, let's continue. Yes. Yeah, so I would say this is hardest. The most dimension we can get. F is a function of 3 variables, and x, y, z, they're also a function of 3 variables. Okay, so I would say those are the most variables I may ask you for the chain rule. Okay, next. Implicit differentiation. We call that if x and y are related through an implicit relation, such as sine xy plus 3 pi y squared equals 7x cubed minus 11. So you cannot solve for y in terms of x, or you cannot solve for x in terms of y. Okay, then dy dx is computed using the implicit differentiation. There is another way to compute dy dx is to define the function. So you define the function f of xy equals the left-hand side of, so you have an equation, okay? Implicit relation, okay? Then you define your function f to be the left-hand side of the equation minus the right-hand side of the equation. Okay, so this is the rule. Let f be differentiable on its domain, and suppose that f of xy equal to 0 defines y as a differentiable function of x. Provided partial f partial y is not 0, then the derivative of y with respect to x equals negative partial f partial x divided by partial f partial y. Why is that? So keep in mind, because f of xy equals 0. Now let's take the derivative with respect to x. Okay, and here we need to do a chain rule. Okay, so that is partial f partial x times dx dx plus partial f partial y times dy dx. Okay, so that's the difference than just taking this is, okay, what's this guy? This is taking the derivative, so partial derivative with respect to x. Okay, so here we consider x and y, they're both independent variable. Okay, but here when I say take derivative take the derivatives back to x, I mean y is a differential function. So we consider y is a function of x. So you consider the f is just a single function of x. So only x is the independent variable. So not the y. Y depends on x. Okay, y depends on x. Okay, so on the right hand side, the derivative of 0 is 0. Okay, so that's why we need chain rule in this case. And now you can see dx equals 1. So let's continue here. Fx plus fy dy dx equals 0. And then we can move the fx on the right and it becomes negative. So we can solve for dy dx is minus fx over fy. So far so good. Let me use different color to, okay, so this is, yeah, I'm afraid you're confused. So that's why I put, even though here we're taking derivative, we take the ordinary derivative with respect to x. Okay, and here this guy is taking the partial derivative with respect to x. Okay, so let's continue. So this provides us a different way to solve the problem. Okay, instead of implicit differentiation we learned in Calculus 1. Okay, so now we already have the f defined. So what's f? Partial x. Well, we consider x is the variable, so derivative of sine is cosine. And because of the chain rule, xy prime becomes y. And then this guy has no y, so we have derivative of that is 0. And then we have 3 times 7 is 21x squared. And derivative of 11 is 0. Okay? How about fy? Fy, the derivative of sine is cosine xy. Chain rule, xy prime. So derivative of y is 1, so we're only left with x. And then 2 times 3 is 6 pi y. Derivative of these guys is 0 because they're constant term. Okay? So now dy dx is then minus fx. So cosine xy y minus 21x squared over cosine xy x plus 6 pi y. Okay, so far so good. You might ask, yeah, this is kind of easy, but why do we want to use this method? If you can remember how did we use implicit differentiation to find this? You will see, you can compare both and you will see why. I can show you here. So let me show you here. So kids, I really want you to see the difference between this new method and our methods before. Okay, let me use a different color. So in Cal 1, okay, so in our Cal 1 method, so we start with this guy, right? And what did you do? What would you do? The implicit differentiation. You take the derivative with respect to x on both sides, okay? And then so derivative of sine is cosine xy, but then you need to do xy prime because of chain rule. And then we have 3 pi derivative of y squared is 2y times dy dx. So whenever you take the derivative of y, you need to include dy dx. So when you take the derivative of x, you don't need to include dx dx because dx dx is just 1. So 7x cubed is 3 times 7, 21x squared. So you don't need to include dx. Okay, derivative of 11 is 0. Next, this guy. Actually, we need to do product rule. Okay, because y is a function of x and x is a function of x. So first guy prime, second guy plus first guy times second guy prime. 6 pi y. Let's use y prime. Okay, that's easy. Let's save more work. Okay, now x prime is just 1. Okay, so what do you do next? You're gonna distribute. So cosine xy times 1 plus cosine xy times xy prime plus 6 pi y prime equals 21x squared. Then what do we do? You see the terms with y prime? Keep it on the left hand side. For the terms without y prime, okay, for the terms without y prime, move to the right hand side. And let's see. What do we have now? So we have, because the terms on the left all have the y prime as a common factor, we can factor that out. And then the right hand side, we have 21x squared minus cosine xy times y. So y prime is 21x squared minus cosine xy times y and cosine xy times x plus 6 pi y. So this is what we would do when using the method we learned in Calculus 1. Let's check our answer. See? The denominator is the same. The numerator, you see this minus. So when you distribute the minus in it, then you will get the same answer. Okay, everybody. So we do get the same answer. And you compare which method is easier. Yeah, our new method is easier because you don't need to do the chain rule and do the product rule and distribute the terms and move the terms to the right hand side and factor and divide. Ooh, that's a lot, right? So I hope through this example you can see the beauty of our new method. Okay, let's continue. Alright, so let's look at this example. F of xy equals that. Okay, so let's find fx. Okay, so 7. Secant derivative is secant tangent. So secant xy squared minus 4 tangent xy squared minus 4 times chain rule xy squared minus 4 prime. But this prime is with respect to x. Okay, with respect to x, derivative of x is 1. So this is just y squared. So far, so good, everybody? Oh, and so I forgot the second term. Derivative of ln of x is 1 over x. So far, so good, everybody? So sometimes we really need to check our work because sometimes if we're not careful enough, we might miss some terms, especially when the problem get more and more complicated. Yeah, after you write a long line, you think, oh, I'm done. Is it really done? Okay. What's Fy? Okay, so it's still chain rule, right? So secant that term, tangent that term, then chain rule that term, prime, and then derivative of ln of x is 0. But this guy, this prime is with respect to y. So we have 7 secant xy squared minus 4 tangent xy squared minus 4. This is 2xy. Okay, we still have the x. And then Finally, dy dx, which is minus first guy 7 secant tangent y squared plus 1 over x over the second guy we calculate secant tangent and 2xy. You can also combine the 2 and 7 together as become 14. Okay, but it's okay if you leave it like that. So far, so good, everybody. So today we learned about chain rule and we talk about a new method to solve implicit differentiation. Alright, so please go ahead and do your homework. If you have questions, please print screen and you can ask me in class or in office hours or send me an email. Have a nice day. Bye.